Alright, two objects were projected vertically upward at different times with speed of 80 meters per second and 100 meters per second respectively. If the time interval is 2 seconds, where and when will they meet? Alright, so to solve this question, we have two questions here. The first one is where, and where talks about location, which is distance, and when talks about time. So we are asked to look for the time and the distance where these two objects will meet. So first thing that we need to look at here is two objects. So since we have two objects, that means we have two initial velocity. For the first object, the initial velocity is given as 80 meters per second. Then for the second object, the initial velocity is also given as 100 meters per second. Two objects were projected vertically upward at different times with speed of 80 meters per second and 100 meters per second respectively. Now if the time interval is 2 seconds, the time interval simply means the difference in time between the first object and the second object. So time interval is t, which is t1 minus t2. This is time interval, but we have t now, which is the time interval to be 2 seconds. So anywhere we see t here, we replace t with 2, and from there we can make t1 or t2 the subject of formula. Then at the point where they will meet, at the point where the two objects meet, we are going to have x1, distance on the first object x1 to be equals to the distance on the second object x2, but distance for a falling of x is ut plus half gt squared, falling under gravity, and the initial velocity has been given u1 and u2. So what we have to consider is we have to consider the two objects. Distance for the first object x1. Now x1 will be the initial velocity for the first object u1, then with what, t1. Since the object is falling, g becomes negative minus 1 over 2 g t1 squared, but time interval, which is t, it is t1 minus t2. Then I can have t2 equals to t1, then you bring this t inside, minus t. Call this equation star and star. So t2 here will be t1 minus the time interval is 2. So anywhere we see t2 in the distance for the second object, which will replace with t1 minus 2. So come back to this equation 1. Now let's finish with that. x1, the distance is going to be the initial velocity is 80 with t1 minus half, g is 10 times 10 t1 squared. So if we divide this, I'm going to have x1 equals to 80 t1 minus 2 here 1, 2 here 5. So I have 5 t1 squared. Now we have gotten a straight equation for the first distance x1. Call this equation 2. Now let's consider the second object. For the second object, distance s2 will be u2 t2 minus half gt squared. So x2 now, the initial velocity u2 is 100, then t2 is t1 minus 2. So we'll put that t1 minus 2 then minus half GT. If you put 10 here and you divide it by 2, that will give you 5, so that will save time. 5. Then T2 is also T1 minus 2, but this has square now. So how do I simplify that? What I have here is T1 minus 2 then squared. That is for this part. If I'm to simplify that, this is equivalent to T1 minus 2 with another T1 minus 2. So if you open the bracket, you have T1 squared, then T1 times this minus 2T1, this again times this minus 2T1, then minus times minus, which will give plus 4. Simplify this, so we have T1 squared minus 4T1 minus 2T1 minus 2T1, then plus 4. So anywhere we see T1 minus T2 squared, we replace it with this expression. So we'll come back to this part again. So you have x2 equals to 100. If you open the bracket, 100 T1 minus 100 times 2 will give you 200. Then minus, we have 5 in bracket of T1 squared minus 2 squared, which is going to be this value, T1 squared minus 4T1 plus 4. So open that bracket, x2 will be 100 T1 minus 200, then this 5 will open this bracket, minus 5 T1 squared minus times minus, that is plus 20 T1, then minus again times plus, minus 20. So at the point where they will meet, at point where the two objects meet, we are going to have distance of the first object to be equal to the distance of the second object. That is the only condition for them to meet. So distance for this first object is this, and distance for the second object is this. So x1 now, copy the value, which is 80 T1 minus 5 T1 squared, that is all for x1, equals to x2. We have it here. You can add this together, minus 5t plus 20, oh, this t square and this t, so we can't add that. So you have 100 T1 minus 200 minus 5 T1 squared plus 20 T1 minus 20. So if we can collect the like terms here, you have 80, collect like terms T1. Where do we have another T1? We have it in 100 and we have it here in 20. So positive coming over here, minus 100 T1, then negative positive coming here also, minus 20 T1, then you have minus 5 T1 squared, negative here, then you have minus 5 T1 squared, positive here, comes over, it becomes negative, it becomes positive 5 T1 squared. Then we are left with 220, so which could be equals to minus 200 minus 20, which will give us minus 220. So for this part, we'll simplify 80 minus 100, that will give us minus 20, then minus 20 minus another 20, that will give us minus 40 T1. Then what do we have here? Negative 5 T1 squared cancel positive 5 T1 squared, so the quadratic aspect is out, so we are left with 200 minus 220. So negative here, cancel this negative, so I'm left with 40 T1 equals to 220. So divide both sides by 40, T1 will be 220 divided by 40. Okay, so let's cancel out 0 here, cancel this 0, then 2 here will give me 2 here will be 11, so 11 divided by 2 will give 5.5, and time is in seconds. So this is the time when the two bodies will meet. This is when now. So if we need where, just put the value of t into any of the equation. Either you put the value of t for the distance x1, which is equals to 80 t1 minus 5 t1 squared. If we put the value of t1 here now, that will give us where, or you either put it in equation 2, any of them will give the value, but you can now say t1 is 5.5 seconds. So put that here. Distance x1 will be 80 in bracket of 5.5 minus 5.5 squared. So all I'm dealing with now is 80 times 5.5, 80 multiplied by 5.5, which will give me 440 minus 5.5 squared. 5.5 squared will be 30.25, then multiply by 5. That will be 151.25. Subtract that, 440 minus 151.25, and that will give you 288.75, and that is what, in meters. So where is talking about distance, where, that is distance where the two objects will meet. Where is now 288.75 meters. At this distance the two body objects will meet. And then when talks about the time, so when the time for the two objects is 5.5 seconds, they will also meet. You can try the other equation, which is equation 2. You will still arrive at 288.75.